Hello everyone, in this video we're going to study triangle congruence by HL Theorems and CPCTC. This one stands for corresponding parts of congruent triangles are congruent. If two triangles are congruent, then their corresponding parts of congruent triangles are congruent. We're gonna say CPCTC, which is the first letter right here, CPCTC, right? So, if triangle ABC congruent to triangle DEF, then you have side AB right here congruent to DE, right here. AC congruent to DF right here. And BC congruent to EF right here, right? You also have angle A congruent to angle D right here. Angle B congruent to angle E right here. And angle C congruent to angle F right here. That's equal CPCTC, right? Now we're gonna talk about the HL theorem, which is hypotenuse-Leg in right triangle theorem, right? If two right triangles ACB and DFE have hypotenuse right here and hypotenuse right here congruent, right? The leg right here and the leg right here congruent, right? We only need two elements, that's it. Then two triangles ABC congruent to triangle DEF by HL theorem. So, HL theorem says, if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and one leg of another right triangle, then the two right triangles are congruent. Example number 1, determine whether triangles are congruent. Alright, so we look at this one right here, we see that these two triangles right here are right triangles, right? Because we have angle B congruent to angle R, right? Equals 90 degrees, right? Now we have AB congruent to PR, right? We have the hypotenuse right here, AC congruent to PQ, right? So we can conclude that these two right triangles right here are congruent by HL theorem, right? Example number 2, we're going to use the flowchart to prove parts of triangles congruent. Alright, given angle KBC, which is this one right here, congruent to ACB, which is this guy, right? Angle K right here, congruent to angle A right here. We need to prove that KB congruent to AC, which is this guy and this guy, right? In order to prove these two sides congruent, you need to prove that two triangles containing two sides right here are congruent. Then you're going to use the CPCTC, right? So, we're going to consider triangle KBC and triangle ACB, right? We have angle B right here congruent to angle C right here given, right? We have angle K right here congruent to angle A right here given, right? And we have side length right here, BC right here, congruent to itself by reflexive property, right? Then triangle KBC congruent to triangle ACB by AAS theorem, right? Then you can conclude that KB congruent to AC by CPCTC, right? Now let's move on to example number 2. We given angle TRS and angle TRL are right triangles, right? So this one is 90 degrees, this one 90 degrees, right? Angle RTS congruent to angle RTL right here, right? And we need to prove that S are congruent to RL, right? So I put a question mark right here, right? They're not given. Yes, we need to prove it, right? In order to prove that RS congruent to RL, we need to put RS and RL into two triangles, right? So those triangles are TSR right here, and another triangle TRL, right? So then we can use CPCTC to conclude that RS congruent to RL, right? We're going to start with the given thing right here, right? Now note that in this situation we cannot use HL theorem. Why? Because we don't know if ST right here congruent to TL. So we're going to use another theorem that's called ASA theorem, right? Now observe that TR congruent to TR by reflexive property, right? Now given these two angles right here are right angles, then we can conclude that this angle congruent to this angle by definition of triangle, right? So then we can conclude that triangle STR congruent to LTR by ASA theorem, right? Look, angle, sine, and angle right here, right? Since these two triangles are congruent, we can conclude that SR right here congruent to LR right here by CPCTC, right? Look, SR and LR, right? Now let's move on to example number 4. Write proof using HL theorem. Alright, in this situation, I'm going to use the flowchart to prove these two triangles are congruent, right? Now, given BE bisect ADSC. So BE bisect ADSC, it tells us that AC congruent to CD, right? Now keep in mind, students always make mistake. They say BE bisect ADSC means BC congruent to CE. That is not the case. So you need to be careful. Now since AB perpendicular to BC, right here. DE perpendicular to EC, right here. We can conclude that angle B and angle E are right angles by definition of perpendicular lines, right? Then we can conclude that triangle ABC and triangle DEC are right triangles by definition of right triangle. AB congruent to DE given, right? Now from these three guys right here, we can conclude that triangle ABC congruent to triangle DEC by HL theorem. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.